ElRobot friends. Today I'm talking about another concept in teleoperation, which is gravity compensation. We've seen that in the previous tutorial, and this is a follow-up tutorial based on the ElRobot teleoperation platform, which is great. I think it's one of the best open source project and is sort of inspired by the ElRobot. I have one leader R right here on my other side. I have two cameras today. I don't have the follower built in because I don't want to damage anything during this experiment. But what I implemented is something called gravity compensation. So what is gravity compensation? Is this uh, let's say process where essentially you and sorry, let me remove that one, where essentially you can move the arm and you can keep the actual you can essentially compensate for the gravity element that applies to your leader arm, uh, and as you apply an external force, which is your hands, the arm stays in that position. And so how does this magic work? Well, it's kind of simple. You can go and check the repository, and the motors they're using are more expensive than the ElRobot, and they have this feedback control called torque control. So torque control is another type of PID control, which is very used in industrial robotics. But essentially, you can tell each motor to keep a certain level of torque, which is the force. Um, and so what you can do is to say, well, I want to, I have this gravity vector which I can calculate, and I want to subtract that from the whatever torque is being applied to this kinematic chain. And by doing this operation, essentially the arm stays in place. Now you are going to say, well, okay, but one way to do that is to maybe fix position. So I can say, well, I want to stick my arm in a specific position like we did before. And so what I can do now on this arm, let me show my camera, is to say, well, I'm going to put a web controller, and now let me move it maybe. I'm going to move in this position, and I'm going to essentially stick position, and that thing works. So this is great in practice, but then if I want to move this, I can actually move it, but I'm going to break it. So either the gear will break, or there will be what is called a feedback current, and it's going to damage the up to a certain point. It's going to damage those motors. But these motors are cheap. They don't have torque control, only position control. So right now I'm in position control, which I can also change from here. So I can change the arm, like I can impose any position I want. So how do we implement gravity compensation? So I went online and searched also with the help of Claude of several algorithms, and the idea is you use math. So do you know the actual geometry, so the inertia and the center of mass of this kinematic chain, and you can essentially approximate the gravity vector and try to compensate for it. Now, this is not perfect, so it's low cost, but of course, you can expect some strange behavior sometime. So, what I found out was that if you set a specific gravity factor for each element in the chain, you can have a workable solution where you can have gravity compensation even for this very low cost solution. So I'm going to go self control. So this is floppy. And so as you can see, each motors in the chain, except for the gripper, because I don't need anything to compensate for that gravity, is has a constant. So this is the gravity constant. If you put this too low, essentially it's going to be too supple. It's going to be too soft, and it's not going to be able to compensate. So what I'm going to do now, I'm going to enable gravity compensation here, and you can see this is now in place. I'm not going to do anything. There is some drift sometimes. And let me try to reset it again. And and let's try again. Sorry, I was fiddling with some settings. So I am now in a position like that. Okay, so yeah, as you can see, there is some drift. Now, how do I fix this? Let me show you. So I'm almost there. Look at this. So if I put in this position, it's keeping it. I do feel this one is moving a little bit, but is not too bad. I can sort of, oh, yeah. So you can see this motor now is giving too much way. Let's see if I can put it again. So it's very important to fiddle with these parameters, which is, I guess, one of the one of the backside of doing that in software. But if you play with this carefully, you can achieve something that is kind of decent, right? So I'm moving it, and it's keeping the actual gravity. Of course, you will feel some a little bit. Obviously, it does have kind of like a force feedback, compared to having like totally passive, but it's not too bad. I can have, like, I can move it. Is not, I mean, I just have to apply the degree of force, um, and it stays in place, which is nice. Now there are certain angles that don't work well. I don't know if it's a limitation of the algorithms or the feedback of these motors. Um, but yeah, you need to play with this one. So let me do another one. So I have increased some of the parameters here. So now in this very sort of tough diagonal position, it's giving up a little too much away. Um, let's increase it, but you can see, like, if I remove it, right? Let me try another weird position. It will be like this. Yeah, it's going back too much. So it's not perfect, of course. This is a software compensation, but um, if anyone wants to give it a go, obviously it's all open source, and it's a good start. It's not perfect, but I leave you with this magic here. So I hope you found this interesting, and you can take a look at the code and the source code and contribute back to this project. And just don't forget to like and subscribe. Thank you, and see you in my next tutorial.